Hello out there to everybody, and welcome to this our video today in our YouTube channel. In today's video we shall be looking at how we can come out with this very important hyperbolic trig identity, which the inverse trig identity, which says that we should show that cosh inverse of x is the same like the natural log of x plus or minus the square root of x squared minus 1. Okay guys, please, just for a quick reminder, please, if you're new to our channel, please make sure you hit the subscribe button right now and press the notification icon such that each time we upload videos you'll definitely be the first person to be notified. And guys, please give this video a like. Just please press the like button just beneath this video, because that is your own gift to me, right? Yeah, thank you. That is your own gift to me. So now let's dive straight into the video today. Okay, now guys, to be able to answer this our question so well, it will be so good if we can now for us to show that cosh inverse of x is the same like the natural log of what we have here. It will be so good for us to take the left hand side and show that it is equal to the right hand side. So by so doing, now we are going to start by letting y to be equal to cosh inverse of x. Good. So we are going to let y to be cosh inverse of x. That therefore means that if we take the original cosh on both sides, we are going to have our cosh y to be the same like x. Great. And guys, we should recall that cosh y from definition is given as 1/2 into e raised to the power y plus e raised to the power negative y. So guys, this is the definition of the hyperbolic cosh of the hyperbolic cosine of y. This is its definition. Okay, now guys, if we now proceed now, we are simply going to have 1/2 e raised to the power y plus e raised to the power negative y equal to x. Keep in mind that we recalled that cosh y was the same like what? 1/2 into this, but this cosh y up was equal to what? X. That therefore means that this everything here has to be equal to what? X. So it is exactly what we have here. So guys, if we multiply all through by 2, we are going to have e raised to the power y plus e raised to the power negative y equal to the 2 multiplies x here to give us 2x. Good. So now if we further multiply all through by e raised to the power y, we are simply going to have e raised to the power y times e raised to the power y, which is e raised to the power y, all that squared, plus e raised to the power y times e raised to the power negative y. Indices is going to come in. The bases are the same e. We add the powers. Negative y plus y gives us 0. We have e raised to the power 0, which simply gives us 1 here. Then here equal to 2x, then e raised to the power y. That's great. So now if we send 2xy inside, we are simply going to have e raised to the power y, all that squared, minus 2x e raised to the power y plus 1, which gives us 0. Good. Now guys, we can let a suitable substitution, because at this point in time we can easily recognize that e raised to the power y, all that squared, minus 2x e raised to the power y plus 1 equal to 0. We can see that this is a quadratic equation in terms of e raised to the power y. But if you cannot see it so clearly, we can let our substitution, we can take e raised to the power y to be we can take any variable. We can, in this case, like I said, I've taken the start of my name. Yeah, so I've just taken m, capital M. That therefore means that if we substitute m into all the e raised to the power y's, we are simply going to have m squared minus this is minus 2x is a constant, so we still have the 2x here. Then e raised to the power y is given as what? M. So that's why we have the m here. Then plus this one which is here equal to 0. Now guys, we can solve for m using a quadratic formula. So we are simply going to have m is equal to, the quadratic formula says that it is going to be negative b. What is our b? Our b is negative 2x, so it's going to be negative, which gives us positive. That's why we just have 2x here, plus or minus the square root of b squared. Negative 2x, all that squared, simply gives us 4x squared. Then minus 4ac. Keep in mind that a is 1, c is 1, so we simply have minus 4 here, all that on 2. Good. So this is what we have, guys. And now if we factor out a 4 from inside here, if we factor out the 4 from inside here, the 4 comes out as what? 2, because the square root of 4 is 2. Good. And this 2 is going to cancel here, cancel with the one we have here, and cancel with the one we have down. So in the end result now, we are simply going to have our m to be equal to x plus or minus the square root of x squared minus 1. Good, guys, but keep in mind that this our m here was what? E raised to the power y. So we simply put back, we have e raised to the power y equal to x plus or minus the square root of x squared minus 1. Great. Now guys, in this case now we simply take the natural log on both sides, because keep in mind that we are solving for y, right? We are solving for y, so we simply take the natural log on both sides. So we are simply going to have, if we take the natural log on both sides now, we are simply going to have y, because the y comes down, to be like the natural log of x plus or minus the square root of x squared minus 1. Great. So this is what we have, guys, but don't forget that our y is what? What is our y in this case? Our y is cos inverse of x. Great. That therefore implies that but guys, let's keep in mind this is an important argument. We know for sure that for the natural log function to be defined, what should be inside the function must not be less than or equal to 0, right? Great. Now we can lay our claims that x is bigger than what? Than the square root of x squared minus 1, right? Yeah, you can further verify that, because if you square both sides, you're going to have x squared to be greater than x squared minus 1, and it's a true statement because you simply have x squared on the left hand side, then on the right hand side you have what? The same x squared but minus 1. Means x squared is always less than what? X squared is always greater than what? X squared minus 1. Good. So now if you can able to see this claim here, that since our x is bigger than x squared plus 1, it therefore means that, and we can bring forth other conditions by saying that x in this case must be what? X in this case must be greater than 1. Great. X in this case must be greater than 1. X in this case must not be 0, because if x becomes 0, the square root of negative number does not exist, and natural log of it still does not exist. So we can lay further claims that our x in this case is what? Is strictly greater than or it is greater than or equal to 1. Good. Yeah, so that's the domain of x, all real numbers such that all values of x for which x is greater than or equal to 1. Good. Now guys, if we've understood the reason for this inequality here, that therefore means that we can go ahead to substitute our y with what? With cos inverse of x. That therefore means that we are simply going to have our cos inverse of x to be the natural log of x plus or minus the square root of x squared minus 1. So guys, this is the proof in which we have, this is it. This is the proof in which the equation wanted us to prove. So thank you very much guys for watching the video, and I hope you enjoyed it. If you enjoyed it, let me see in the comment section. Just indicate in the comment section that you enjoyed it. If you didn't enjoy it, still put it in the comment section, and I'm going to look for ways through which I can make it in a way that you're going to understand it more. Just leave it in the comment section if you want me to attend to anything, and I'm going to do it. Thank you very much once again guys for watching, and please, if you've not subscribed to our channel at this point in time, please, I highly encourage you to subscribe to the channel now, because we are going to be uploading so many interesting contents in this channel, and you can only have access to those contents once you've subscribed. If you've not subscribed, you will hardly see them guys. You won't see them even. You won't see them. And please don't forget to like the video. Just press the like button beneath the video. That way it is going to motivate me enough. It is going to tell me that you actually found the content useful and I should keep making them, and I'm going to continue doing that for you guys. Thank you very much and have a great day.